Okay, we're going to do something a little different in this demonstration. We're going to actually derive the quadratic equation from the standard form. I'm sure someone will find this useful somewhere. Anyway, just to make sure we understand our terms, this is called the standard form of a quadratic equation. This formula is known as the quadratic formula. And what we want to do is see if we can get from the standard form to the quadratic formula. Okay, it's a little bit of an involved process, but let's see if you can keep up with what I do here. So let me just rewrite this. Okay. Now, if we want to solve for x, and we've got all letters, what do we do? Well, the first thing we do is what's called completing the square. Right? We're going to get the c over to the other side, so let's start doing that. I get ax squared plus bx plus something is equal to negative c plus something. Okay? Now, if we could complete this square, we would probably find out half of this and square it, but we got an a here, so we need to factor out the a first. Let's do that. And that's going to give me x squared plus, now this is where you might be a little confused. How do you take out an a when there's just a b there? Well, it's the same thing as dividing by a. Now let's see why that is. If I were to go a times b over a, the a's would cancel out, and I get the b again. Alright, so yeah, it does work. Alright, let's continue here. And that's that side. Now, in the next step, according to completing the square procedure, you're going to take half of this, which is just b over 2a, and then you square it, which gives me b squared over 4a squared. So here I've got b squared divided by 4a squared. And now, whatever I added to this side of the equation, I want to add to that side of the equation. Now look what I did. I didn't just add b squared over 4a squared. I added a times that to this whole side of my problem. So I want to add that same amount over here. That's going to be a times b squared over 4a squared. Now, I'm going to reduce this just a little bit because that's like saying negative c plus ab squared over 4a squared. I can take an a out of there, and I have b squared over 4a, and then the negative c over there. On this side, I'm going to take the factored form of that perfect square trinomial. It looks a little complicated, but remember how we do it. You just take half of this squared goes here, half of this goes into the factored form. So it's going to be x plus b over 2a quantity squared, and there's my a. Okay? Step 5 we said was that part. Let's go with step 6. Now I want to take the square root of this side and this side, but actually what I think I first want to do over here is add these two things together. So I'm going to multiply that negative c by 4a over 4a. And that's going to give me minus 4ac plus b squared over 4a. It's starting to look kind of familiar here, I think, isn't it? Or maybe not. Anyway, so let's move all this down to here now. X plus b over 2a quantity squared. Now, if this were just a regular problem, and this actually is just a regular problem, I'm going to take the square root of this side, but I've got an a out here. So let's divide both sides by a. That gives me x plus b over 2a quantity squared. If I divide this by a, it's just like multiplying by 1 over a, so I get this. And let's rearrange the top. Okay? Take a look at that again, make sure you did that. If I'm dividing by a, that goes away here. It's like multiplying by 1 over a, so that just makes that a square. Take the square root of both sides. And that gives me x plus b over 2a is equal to the square root of b squared minus 4ac over the square root of 4a squared. That's almost done. I'm going to get x plus b over 2a is equal to the plus or minus the square root of b squared minus 4ac all over 2a, because plus or minus is the square root of 4a squared. Then I subtract this. You get negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Put that under the same denominator. And there's your quadratic formula. So if you want to review this a couple more times, I'm sure you'll eventually get it. All right? Good luck to you.